Hi everyone, and you're all very welcome to today's MasterSeries 2024 preview webinar. We really appreciate you taking the time to join us here today. Very much appreciated indeed. My name is Martin O'Gara. I'm a director with Civil and Structural Computer Services, and I'm also lead up the development team for the MasterSeries software product, and I'll be taking you through the webinar today. As usual, on your GoToMeeting or GoToWebinar control panel, you've got your questions box. You can type questions as you go. We've got panelists. My colleague Andres Herbe is joining me there to answer your questions as they come, but they will also be rounded up and answered in the follow-up email that comes after the webinar is completed. As usual, we're being recorded, and this will be posted on all the usual channels, and you'll get a notification of that also. The MasterSeries 2024, when it's released, you can find out all of what's new by going to resources, clicking on what's new, and scrolling down through the full list of what's new features here, and you'll get a full flavor of what's coming there. We'll just be looking at a few of the highlights of that today. First up, one of our major new features is the implementation of the SCI new wind analysis toolkit released just a few months ago called SCIPHRY. And this replaces the legacy Breve wind analysis tool that MasterSeries previously used. It is a web-based API, and it's, if you like, a behind-the-scenes analysis engine, just like Breve was that our software integrates with to do the wind site analysis. So using a web-based API obviously has several advantages in that all of the site data information can be automatically kept up to date and maintained with that operation not being performed on your actual software on your PC, but on the web. The SCIPHRY tool obviously is a huge step forward in that it modernizes brings up to date the data for the wind site analysis using information from online map resources. The terrain analysis has been refreshed so that you're getting up-to-date distances to town, sea, country. It also brings online some nice new features for postcode searching, as well as the traditional national grid reference, latitude, longitude, and Irish users also get air codes, the ability to search based on those also. Our own implementation of the refresh to include the SCIPHRY has enabled us to do a complete root and branch rewrite of our MasterKey wind site analysis end of the business. So we've got a brand new interface there for that, including our implementation of showing you Google Map images of a road map and a satellite map that you can see there, which are actually useful in terms of locating sites, not just showing you a picture of where you're at. So we've got a refreshed and rationalized user interface there as well. So let's take a look at that in action. So noting that we're using the SCIPHRY, the design output has been rationalized, nomenclature has been improved, and clarity has been increased as well. A lot of the unnecessary wind heights have now not been analyzed where not needed. We can see here on our roadmap, we're zooming out, you can see the distances to town, sea, and country and how those come across to our terrain analysis. Looking down at the tabs, you can see a lot cleaner interface here. Everything has been re-laid out. Things have been moved around into more sensible places, and everything is decluttered and reduced and much more streamlined. So we also then obviously have options of which methodology of wind site selection you want to use. So using postcode, we can quickly search for, we'll just go to our office postcode here, BT38 7BE in Carrickfergus, and entering that, it's going off to the web analysis and updating the site calculation. As you can see, it's very quick, but this map can also be used to select the site. So we're going to select a slightly alternative site here and clicking on the little locator icon to resync those maps and update the analysis. And that's the wind site analysis complete now for our chosen site that we've chosen from the Google map. So just a note as well to say that the SCIPHRY calculation, obviously using more up-to-date data. As you open up your existing MasterSeries data files, those will be migrated across to the new SCIPHRY wind site analysis. You will be notified of that, and you'll be asked to check the potential variation. You might get some slightly different wind pressures with that coming into play. So, and the backup of your original file will be maintained, so for you to compare the two between MasterSeries 23 and 24. Next up, we've got MasterFrame and some of the work that's been done here. We've had quite a wide range of a rewrite of a lot of our geometry-based editing functions, more under the bonnet type work, but necessary work to modernize our code base. That modernization of the code base has resulted in an update of the interface across many of those commands. Probably the most prevalent of those in terms of appearance is our nodal conditions editing interface for nodal loads, support springs, and settlements. A really nice new modern interface for that, as well as some nice new tools for actually locating those conditions by searching for a node using the graphical selection. Our steel sections selector interface that's used not just in MasterFrame, but also steel design, composite design, anywhere where steel section selection is required, has had a major update as well. We'll just have a look at that. So let's have a look at the nodal support conditions first of all. And obviously we're in the condition here. We can get to here by going to loads, nodal loads. So this is nodal loads being one of the flavors of a nodal condition, but we also have our supports, springs, and settlements. So in this model here, we have some nodal loads already applied. Dropping the list here, we can see we've got 4 conditions. So this is just really a new interface and what was there previously with all the same functionality, but with the new find mode just briefly highlighted there. So with our 4 conditions, scrolling through those, you can see those blue arrows indicating where those loads are applied at. Quite a busy frame. This could be a very we've only got 4 nodal loading conditions here, but we potentially could have, you know, upwards of 50, 100 on many, many nodes across the structure. Just going to a snapshot here so we can zone in on this a little more to demonstrate potentially how this find mode might be used. So clicking on a node, you can see the condition that's highlighted there changing as we're navigating to the condition that's on the node that we applied to. And indeed, this node that we're clicking on now has 2 conditions, and it's actually toggling between those 2 conditions as you click each time on that node. So that's a really nice new facility, the find node facility there. Moving on then to the steel section selector, just a brief reminder of what the old steel section selector looked like. Quite a busy interface that took a little bit of getting used to in terms of navigating your way around, led over these 3 rows of controls. That has been fully reworked into a more modern and we feel much easier to use interface. So all the main features of haunches, casing, secondary sections, plated sections, cellular sections, and discrete openings are now obviously available in a similar fashion to what was previous. But when we activate any of those, everything's nicely organized into a better controlled system in its own group boxes. And we'll see what a few haunches looked like there. Now we're popping on some secondary sections. These types of facilities are as per MasterSeries 2023, but the ways in which you interact with them through the system is much improved. So popping on a bottom plate on this member that has a top channel section. Here's an example of a cellular beam and the inputs that are involved there. And we're just popping in there a discrete web opening, again, just demonstrating the new interface with regards to the steel section selector, and just with that elongated open in place. The final thing then is just showing the casing sections on that with the section sizes demonstrating the casing is in place. So again, all of those types of sections are as per MasterSeries 23. However, the ways in which you interact with the interface has improved. Next up, we're going to look at a really nice new feature that we've been on the wish list for a few years now with regards to wind signs choice in the integration of the wind analysis with MasterFrame. So as you know, MasterSeries has the automated MasterKey wind analysis. In MasterSeries has the automated calculation of the coefficients of pressure. And for certain wind signs or for certain panel orientations, particularly windward facing sloping roof panels and canopies, you get a choice of coefficient of pressure sign. It can either be the standard negative suction or an alternative positive pressure. And there were ways and means of dealing with that in MasterSeries, previous versions of MasterSeries, but now we've improved that to make it a lot easier to consider those variations in sign. Indeed, the Eurocode goes a little further in that it says not only should you consider the standard suction as well as positive pressure, you potentially might also need to consider variations of alternating, where you've got negative CPEs combined with positive CPEs in different panels, and the reverse of that. So that might look like, you can see here, a positive, negative being an alternating pattern. We've simplified that in MasterSeries 2024 by giving you simply the choice of 4 different CP sign patterns. So let's roll the tape. Starting off with MasterSeries 2023, just to give it a context on how this was handled previously, we have a quickly mocked up portal frame here with greens for suction pressure, so negative CPE pressure on these panels. We'll just display those CP values just so we can see that they are indeed negative. And we're obviously looking at wind direction 1, where wind is coming in the x-axis, and the cyan pressure there is the positive pressure on that windward facing wall that we see. Going into the wind panel setup in MasterSeries 2023, reminding you, we have the load CP tab, and the choice of wind sign was controlled by this plus minus input that you see here, and it was tied to the wind direction, which was sometimes a little bit of an issue. And that if we did want to choose the alternative plus CPE, we had to stuff that into a separate wind direction. So now wind direction 5 being in the same direction as wind direction 1, so both being in the 0 degree direction, but 1 being the standard negative pressure, and with wind direction 5 considering the positive. What I'm demonstrating here basically is that that would be set up for each of those panels, but they may have had a need for negative, positive, and how you would have had to achieve that would potentially to use another wind direction 6, whereby for wind direction 6 we want this to be negative, but then positive, negative, positive, negative, positive for wind direction 6. So we're now using another wind direction for the variation of that. And then of course the reverse of that was the positive, negative, and we would have had to use a 4th wind direction. And as you can see, we would quickly run out of wind directions, and therein lay the problem. Not unachievable, but rather unhelpful in the way that it was set up. MasterSeries 2024 with the same kind of model. Now visiting the same wind panel, we have our new CPE sign tab, and we can see here it giving you a little bit of explanation saying where you've got a choice of sign, this is how it's handled. We give you 4 patterns where automatically the software is always calculating the negative and the positive variance where applicable. And then patterns 3 and 4, pattern 1 being your standard negative pattern, 2 being all positive, 3 being one alternation, and 4 being the other alternation of plus and minus signs. So the only choice you've got to make here, and this is the choice the user has to make, is really with regards to patterns 3 and 4, is this panel a negative panel or a positive panel? So we can see here for this panel, we've got a negative pressure for CP pattern 3, but the next one we've got a positive CP for pattern 3, and the reciprocal for pattern 4. As we can see here, going back to that first wind surface, if we do change that sign, it automatically reverses for pattern 4, as it's always the reverse of pattern 3. So how does all that come together? Well, first of all, we can display that using our display of our wind panels. So we're looking here at our positive variant of CPE, and just a note here at the moment to say that that positive variant looked like it wasn't doing positive negative, and that's because there was no choice of sign in that windward or leeward facing panel. But going to wind direction 2, where we do have a choice of positive or negative on any of the spans, you can see those patterns coming into play there. So now let's have a look at the frame load diagram in the wind loads for wind direction 2. So these are the actual uniformly distributed loads on the members from those wind panels, where we actually get to see the final result of the wind load on the members. Here we can choose and see the different sign patterns and verify the SCS. We've got this right. That's positive, that's negative, positive, and this is positive, negative. So how that actually comes to bear then in the analysis is how it's then tied to a loading case combination. So looking at case 7, where everything is negative there, we can see that coming in, but setting it for the case, visiting the load case combinations, and looking at one of the wind cases for wind 1, we can see load case 3 is set here for negative, negative. Load case 4 is positive, positive. And 5 and 6 are the alternations of patterns 3 and 4. And likewise then for 7, we've got wind 2 and we've got the 4 variation. So all of the variation of CPE sign, where you do have a choice of CPE sign now, is mostly and largely controlled by the loading case combination setting, and that makes that job a lot easier. Now, moving on to our MasterKey steel design, this is probably one of the major pieces of work that has been undertaken over the last 12-month development cycle. We've had a holistic internal system rewrite of our steel design. It should be said that that was largely in preparation for the embarking of the implementation of second generation Eurocode, which we'll come to discussing in just a few moments. That holistic review of the system has resulted in some actual tangible benefits to the system in the 2024 version, as we get a full system interface refresh and enhancement. Probably one of the really nice enhancements that you're going to make, like most, is the reworking of the axial with moment and Appendix G or Annex BB unrestrained compression flange check, and that those previous 2 design checks now become one. They get merged together, and which makes the checking of an unrestrained compression flange much more intuitive and not so easy to misunderstand. The 9-portion limit on lateral restraints has now completely gone. We have a much more flexible system for placing lateral restraints and torsional restraints on members. We've got better control over which loading cases are considered as service and ultimate on a design brief by brief basis. We had ways of dealing with that previously, but an improved system for that. And also our steel and composite design group interface has completely been reworked, which is where we'll start looking at that. So we'll have a model here, has a good few steel and composite design groups set up. So let's have a look at that. We can see here for this axial with moment design group that you've straight away got a much more organized set of parameters into all their various categories, with certain information being broken down into subsets for the likes of the bolt holes and the Eurocode coefficients of pressure factors. And you also have nice, more explicit things like a proper drop list for which deflection limit set you want to use, or where you don't have a deflection limit set, then the actual span where value is displayed. So that is much more explicit and much clearer than the ways in which that was presented to you previously. So we've got 26 design groups here. All of the design groups, this was a previous model. All of these have been migrated and moved forward automatically. Looking at a column here, we have a column and simple construction check with all the eccentricities now coming into that and being part of that design group. Strut and tie check, we've got, again, just a few simple properties there as a much more simple check. Worthwhile saying as well, the groups retain their functionality of being able to say that the data is the same for all members across the group, or the section is the same for all members across the group. So those are much more holistic. Now going into steel design, we can see that straight away you're seeing quite a visual impact on the change of the interface, a nice modern interface, updated iconology, items arranged in group boxes, and of course our steel section selector coming in and making use of that in this area. For this axial with moment tab, we've obviously got our axial with moment data tab and our lateral restraint tab. As you can see, everything has been much nicer organized into their respective group boxes in the same way that they were organized into categories in the design brief. Obviously, everything is nicely tool-tipped, and where you have the subcategories, those are now isolated into their own separate little flyout panels, making much better use of the real estate here and making the interface for less commonly used inputs more out of the way. Our full list of effective lengths have been remapped and reorganized. And likewise with the deflection set number, you get a more explicit input for that. And where none is set, then you have the deflection limit being hidden or displayed appropriately, depending on whether you're using deflection sets or not. So again, just a lot of attention to detail there with regards to making that just that little bit easier to use. The lateral restraints tab has been significantly reworked, but we'll come back to looking at that in more detail in just a moment. Another type of check we have here is a column and simple construction check, which is largely a UK type check that is specifically for columns that are in simple construction that have simply supported beams attaching to them. And you can see that. And then again, another variant of a standard check, where a strut and tie check, where you've only got either tension or compression in a member and how that all works. So you can see those are the three main, I suppose, types of design checks. What we now want to look at is our lateral restraint tab. And so having a look at this member that does have a little bit of hugging and sagging intentionally. And we can see here, obviously in this member where we've got an incoming beam halfway, we can do what we have been able to do previously, auto-restrained incoming beams, and we can see then that being set up in its portions. Or turning that off, we can generate the restraint at the incoming points, meaning that then you can edit that or add extra restraints. So it's just a quick helper and a new facility to reset all those restraints to wipe the slate clean again. Now, worthwhile saying, as I said before, we had a restriction of 9 portions there previously, whereas now you have a completely open system for any number of portions that's based on the default of an equal spacing. As you can see, those have been generated as we've input that number, the 1.5 equal spacing with the makeup portion at the end, or we can say we've got a fixed number of those equal spacings. And now you've just got 2 of them, again with the makeup portion at the end. In addition to those equal spacings, let's just take those out again. We also have then the option of inputting variable lengths starting from the first end of the member, and then variable lengths located near the second end of the member. So putting a start portion of 0.5, a second portion of 0.75, we can see those being generated there. And had we then gone down and put in some variable portions at end 2, it might be sensible to specify the number of equal spacings, and then this second variable portions at end 2 would pick up from the end of the equal spacings, filling out the rest of the member. So we can see those all arranged in that manner. Now, one of the things, as we mentioned, was the major step is the amalgamation of the steel axial with moment check with the previous unrestrained compression flange check, which you may have been familiar with knowing as the Appendix G or Annex BB, those being British Standard and Eurocode terminologies in equivalence. Those 2 checks now have been merged into one. So the unrestrained compression flange check is still there as a legacy check because it still obviously will be in your old files. And whereas now those 2 checks going forward, really, there'll be no need to apply that check, because really all you need to do to check an unrestrained compression flange is simply say for this check that these lateral restraints that I've provided aren't on both flanges but are In this case, I'm choosing it for them to be only on the top flange. Those black dots you can see have moved to the top. Also, the restraints now are indicating that we've got some top flange restraints and also now a new bottom flange restraint which spans the full length of the member. So clicking below the line, selected the bottom flange portion of check, and we can see the check obviously is going the full length of the member because we don't have any restraint on the bottom flange. And however, the program obviously, as the previous understrain compression flange check worked, looks at the portion of the member on which the bottom flange is in compression in accordance to the bending moment diagram. And the 0 to 1.25 that you're seeing there is obviously the point beyond the next restraint beyond the point of contraflexure, being the 0.5 plus the 0.75. So we have obviously restraint numbers then assigned to those generated points of lateral restraint. So if we did want to actually put some lateral restraint on the bottom flange at position lateral restraint number 2, we just simply type that into the box, and now we've got a fully restrained top and bottom flange at position number 2, and therefore the understrain compression flange check isn't appropriate in this portion. However, clicking above the line gets us our top flange check, clicking below the line gets us our bottom flange check, which now only goes from 0.5 to 1.25 in this sense. Had that hogging moment being stretched out over a longer part of the member, obviously then you might have had it spilling into right the way through to position number 4. So a really good set of facilities there. Moving on to another new set of features, and this is the migration of something we had previously where we were able to specify which loading cases are considered as design deflection or ultimate service in other language. And how that was controlled was that you added in something called a design deflection loading cases brief. It slotted into the list of loading cases and applied to any of the other loading case or any other briefs, sorry, not loading cases, but briefs, and applied to any other brief that followed after it, which was obviously a little harder to control. Whereas now we have the option explicitly for each individual check to choose something called a case set. And those case sets can be set up. And we've got a few case sets already set up. So they're set up from the edit view, going to edit, design deflection, loading case sets. You always have your default case set, which is the default, what is seen as default service and ultimate cases, design deflection cases from your analysis. But here additionally, we've set up case set 1. We just add the plus symbol to add another set. And in case set 1, loading case 2 has been excluded as an ultimate. And in case set 2, loading case 2, 7, and 8 have been excluded from the ultimate limit state completely. So they won't be included. So what we can do here actually as a really nice way of applying these sets, going back to the default, we can see all the members highlighted that have the default set. But straight from here, we can choose which members or which design briefs load case set 1 applies to and which load case set 2. So we've applied load case set 1 to those 3 members at the front. We can see it obviously has been updated in the drop list appropriately from the changes that we can obviously change it here as well, but it's convenient if you want to do a lot of members to do it through the first method. And obviously we can see here loading case 2 is not listed as we're not have excluded it from that set. This is loading case set 2, and again more cases have been excluded there. Loading case 2, 7, and 8 are now not included for the design of this. That's a much better way to handle that explicit specification of which loading cases we want to include in the design. So that covers our MasterKey steel design update for MasterSeries 2024. All of your existing data for your existing MasterKey steel design MasterFrame files will be automatically migrated and moved forward, and there wouldn't be any, because it's a brand new way in which that data is handled and stored internally in the data file, that obviously will be migrated forward for you. Next up, we've got a really nice new facility called what we call Lean Design Tools. Now, the Lean Design is something that is a terminology that we have borrowed intentionally from the Institute of Structural Engineers Climate Emergency Task Group. One of its key focuses is on obviously reducing carbon, but one of the strategies that it has for doing that is encouraging us as structural engineers to look at lean design. How can we be more carbon efficient in our designs, and how can we reduce the amount of material that we're using? And obviously there's many strategies for doing that. We felt that it would be really good to provide you with some additional tools inside of MasterSeries to try and allow you to home in on areas where you potentially can save the most material. Of course, you have facilities like looking at unity ratios at the moment, and you can look at a design report with your summary unity ratios and see how well utilized your model is. This goes a little bit beyond that and allows you to say a better set of tools for homing in on where the most material potentially is wasted. Now those lean design tools come into play for MasterKey steel design, composite design, and timber design. It is on the roadmap to extend those to the MasterKey concrete programs, those being requiring a little bit more research and thought, given that there's not as much of a relationship between the unity ratio and the material that's utilized. There's much more play there with regards to how much concrete, because really the concrete volume you'd want to reduce as well as the reinforcement, but more so the concrete volume. So that is something that's another step on the line with regards to this. So you get a full report on material design efficiency with overall totals for your design, and you can say easily zone in on the parts of the design where more material is wasted and allow you then to look at that and assess and make changes whilst you're looking at this report. The report is siloed into each of the respective design programs, and that's intentional because we feel these tools are most effective, not just when looked at and you see some numbers, but when looked at in the context of when you're doing your design and when you can make decisions on the spot with regards to what you want to change, and for that report to be instantly updated with regards to those changes. So that is an intentional step there. It has really nice tools for looking at how we assess design groups and how effective design groups are. So let's have a look at that. So the lean design tools, again, we're in steel design. Similarly, they'd be in timber and composite. You can either access it from here or our little green leaf symbol. So the first thing it does, just like maybe doing a print management, it does a collection of all the designs and their unity ratios. So what you're seeing here is a list of the full design briefs, their member length, the section number, the total mass of the member, the efficiency score, which is really just the unity ratio represented as a percentage for each and every design brief, and a total there for the total weight and the total efficiency score as well. Now the thing we obviously want to look at is, well, as we navigate around these briefs as well, the respective report item is selected as well. So there's a good bit of interaction between these two. What we're looking at here is the very low efficiency score items, the ones that are very underutilized. And we can see there are just a few little small members, and they're probably the smallest you see that an engineer could make. So, but they're also not representing a lot of waste material. So this is why this waste material score is quite important. And it is an estimate, but it does a useful way of zoning in. And we can see a member here that has a high wastage, but it's probably the lowest ASB that we could get away with there. And it maybe is something that, well, a different decision could be taken on. Moving on to this member, we can see this has actually been assigned an ASB section as well, and maybe that's not appropriate because it's not part of a floor system. So we can look at this member and just keeping an eye on the member itself, changing it to a UB, and as we do so, the report is instantly updated. Doing a little bit of auto design on that to get it back up to 83% utilized, and we can see that the 400 and something is reduced to 250 kilograms. So that is the mass of the total member, not just the kilograms per meter. So we can see how much material that we've saved there. Looking at this column, which I know to be part of a design group where all the sections are set the same, we now get a standard deviation score for the group, filtered group of members. So it allows us to see, obviously, where that deviation is high, then are all these members really best to be placed in the same design group with the same steel section size. So this is where this is really useful. So looking at the estimated waste, we can see obviously a lot of the upper lifts are obviously quite wasteful, and that's maybe has to be accepted for practical purposes. But then we're looking at the likes of these columns, which are only 40% utilized. Indeed, the most stressed column is only 67% utilized, so maybe there's a bit of efficiency to be made here in any case. We can real-time step through our design groups using our design group tools, and the design report then follows you along with that, showing you your efficiency score for the group and the standard deviation for the group. And again, we're looking at here members that are in this group that, are quite underutilized, but being forced to be that same section size with that group. How do we change that? We can obviously refresh that report for that group and have the report update dynamically as we go through it. So those are really nice tools to really help you reduce the amount of material that's in your design in a practical and sensible way. Just a note then on second generation Eurocodes and where we are with all of that. Obviously, our second generation Eurocodes is one of the largest changes that we have seen coming down the line in our industry for well over a decade since the last issue of the first generation Eurocode. So this represents a 20-year update across the entire range of Eurocodes, with key goals being to update those full range of codes to the latest design research to improve them for clarity and ease of use, and also reduce the number of nationally determined parameters, which is obviously a huge task. We're starting to see those now being released and coming through, including an increase of scope for structural glass. We now have Eurocode, effectively Eurocode 10 for structural glass, and we also have parts in the concrete design for fiber reinforced concrete, as well as higher strength materials being covered across the board as well, and a focus on really things like environmental factors and allowing people to ensure their designs are fit for the future, and also utilizing higher strength materials can be a great strategy for reducing carbon as well. So we see them as a really positive step. We have begun our technical review of those, and we're encouraged by what we're seeing. The current set of releases by the BSI, we can see that largely between the end of November and the end of March is when a lot of the main parts of the code have been released. Still some quite considerable major parts not there. For example, part 1.1 of the actions, part 1.4 of the actions for wind. Probably the main part of the concrete and the fire part are there. Other parts aren't. The steel design probably is the one that has the most parts released. And indeed, we have a new part 113 for the web openings, which is very much welcome. The Eurocode 4 for Composite is set to include a lot of the updated things that we've already known and already implemented in the software with regards to additional non-conflicting complementary information documents from the later research that came out over the years with regards to things like stud reduction factors and partial shear connection modification rules. Those are now going to be embedded into the main part of the second generation Eurocode for composite design. Timber design hasn't been released yet. Masonry did come out quite early, around the 13th of August, and nothing yet on the Eurocode 7. Obviously, all of those are well in progression. The parts that haven't been released are more than likely imminent. None of the UK national annexes have yet to be released, but again, they are likely not too far away. Worthwhile saying that both BSI and IStructE advise that first generation and second generation Eurocodes shouldn't be intermingled with each other. And so that really precludes their use until such time when, well, obviously without the UK national annexes, they can't be used in any case. So you obviously are covered with first generation Eurocodes until 2028 is the current timescale of when they plan to be withdrawn. So as we can see, the second generation Eurocodes are very much at rollout stage and preliminary education and awareness stage. Much of the work that's been completed in MasterSeries over the past year has been really a foundational step towards the implementation of the second generation Eurocodes. Our internal technical review of these documents is well underway, with us working hard reviewing those and getting on top of whether it's critical crack control theory and unreinforced concrete design, or the variety of second order analysis methods that we're now given in the new Eurocode 3 for steel structures. We're really digging into the devil of the detail of those documents as we speak, and that is progressing at pace along with all the other work that's going on. So as the implementation of these updated Eurocodes becomes the focal point of our up and coming 12-month development cycle, we're really encouraged by the enhancements and the clarity and the usability within these design codes, as well as their extended scope. And really our commitment to you as your provider of structural engineering software is really to not just provide you with the software that you need to action these changes, but also to support you through this transition by offering you, additional education material to help you and facilitate with the adoption of these new standards. So exciting times, a lot of work ahead. We're committed to making MasterSeries the software that you need it to be for the next 20 years operation of the next generation of Eurocodes. So the million-dollar question: when will MasterSeries 2024 be released? We're well underway with our internal testing and result verification. Those are being completed. You will see on the webinar follow-up email an invitation to participate in our beta testing program. So if you'd like to register your interest in that with the form that will be provided, we'll update you as soon as that beta testing release is ready. So at this stage, we're probably at a similar stage as to where we were at this point last year, so we can expect release for early August is what we're looking at. It remains for me to say thank you very much. We really do appreciate you taking the time to join us here today. We hope you do like what's coming down the line for MasterSeries 2024. So yes, as I say, we're in exciting times. We've got lots to look forward to and lots to do. And we look forward to getting the MasterSeries 2024 into your hands and what will happen over the next 12-month cycle. Thank you very much.